Hi, I'm Jack, and this is going to be a talk about sentiment analysis. I'm a computer science major, and I'm doing research with Dr. Salia in the department, and we are doing a form of research on sentiment analysis. So I'm just going to talk about the process, and I'm going to show you a bit about my research project. So I'm going to start with describing what sentiment analysis is, what the applications in the real world are. I'll talk over some ethical considerations while using sentiment analysis, and then I'll go over my ongoing research project that isn't finished yet but should give a general idea of how it's applied. So firstly, what is sentiment analysis? It's a machine learning technique to determine the emotional tone of a text. So say I have a tweet or a movie review or like a product review, I can use this machine learning model to determine if it is a positive tweet, a neutral tweet, a negative tweet, sarcastic for some models. Like it's a very broad spectrum of what it can do, but you're just determining the emotion of a certain text. It'll only classify text into the labels that they're trained with. So in my research project, it is split into negative, positive, and neutral. And many machine learning classifiers can accomplish this task of doing sentiment analysis to varying degrees of success. So in my research project, which we'll see, I'm doing random forest, XGBoost, and CatBoost, which are all different machine learning models. So some applications to sentiment analysis are monitoring the public opinions on a product. So sort of like customer reviews, you can filter through customer reviews and see what the overall sentiment of your product is. There's research to what customers like or don't like about your given product. And then you can track opinions of, say, political candidates on social media. Some ethical considerations while using sentiment analysis is wondering how your data was obtained. Was it like legally obtained, or did you find private data and train on that you shouldn't have trained on? Is the dataset biased or not fully encompassing? So if you're looking through tweets, if you're only looking for tweets from specific political orientations or from like just specific people or groups, you're not really encompassing the whole idea on the subject. It's only one like sector of the internet's opinion. And then do the users of your model know how to use it and what its accuracy is? Since it's just a model, it's not going to be 100% accurate, and we'll see that with my project currently. And the users should know what its application is and not overuse its fully they shouldn't overuse the application of your sentiment analysis. All it does is tell you if it's positive, negative, or neutral, nothing else. And if they try to do more than that, then it might lead to some questionable ethics. So yeah, my ongoing research project is we're doing sentiment analysis on a COVID-19 tweet dataset, and we're testing different models to determine which one is the most successful at analyzing these tweets with the highest success rate. And it is currently incomplete, but it should still show the basic strategy of using sentiment analysis in the computer science field. So next up, right here, we got the COVID-19 tweets dataset we're using. And if we look at it here, this one is the negative tweets. So there are 420 negative tweets in the dataset. There are 3,600 neutral tweets in the dataset, and there are 1,900 positive tweets. Here's some examples of the tweets here. We'll see a tiny bit of that later. But yeah, so there's a couple things we'll have to consider. This dataset's very unbalanced here. We got a lot more neutral tweets than negative tweets, so that'll probably have to be cleaned up before we put it into the models. But we'll jump into it here. So this line here, this is just importing a bunch of stuff and reading in the file. This is just showing the top of the data set. So this is what we currently got read in. And then right here, we're doing a few things. We're converting the text to lowercase just to make it a little easier. We're removing punctuation. So we're removing like these at symbols, question marks, all that stuff. And then we're dividing the tweets into 3 different groups, positive, neutral, and negative, based on their label in the dataset. So here's a little bit of an example of what we accomplished here. It's all lowercase and there are no punctuation. Next, we create a vectorizer. What a vectorizer does is we're converting the English text into numbers so the models can use it. So we're just converting it into a form that the models can read. And also, we're just changing some numbers. This is just also for the model's sake in being able to work. We're changing the 1, 2, 3 labels to 0, 1, and 2. Right here, we're splitting our we're making a train test data set. So we're going to use 80% of this data set to train the model, and we're going to use 20% to test it. So we're just splitting up the data randomly, and we're going to be testing on that data. Right here, we're calculating the, so this is where it comes to the data imbalancing. So back with these tweets here, because there are very different counts of all of them, we're going to split them all so we're going to make it so there's all 1900 worth of tweets in all three of them. So we're pretty much going to copy these 420 ones over and over and over again until there's 1900 of them, and we're going to undersample this one so there's 1900 of them instead of 3600. So this is pretty much just the way of doing that. And by the end of it, you can see that before resampling, we had 2900 in the training data of the neutral text, 1500 positive, and 352 negative. And by the end, they were all 1532. So we just split out, or we made the classes equal to one another, so it's easier to train on. And then here, this is actually using the models that we're going to use. Right here, this is our cat boost model, and it's only 2 lines of code, very simple. It's mostly default parameters here. This one's the XGBoost model, pretty close to default parameters. And then right here is our random forest model. So we got 3 different models we're testing on. Just very simply, most of them are just default parameters, and we're just going to test them out. This takes about 2 minutes to run, 3 minutes to run maybe, so not too long. And then here, this is where we get into our testing to see our results. We're testing 4 different things. We're testing accuracy score, precision score, recall score, and F1 score. And you can see all the scores down here. These numbers are not as high as we want. We want them to be closer to 80 to 90%, so we got a lot of work to do. But as you can see, we got cat boost model on this specific run got 66%, XGBoost got 57%, and random forest got 69%. And to visualize these tests, we made confusion matrices. I think we talked about them in class. On the bottom, it shows what our model predicted, and on the left, it shows the actual score. So, for example, here, there were a lot of cases where we predicted that it was negative, but it was actually, right, you can see that they're not all, it should be the diagonal line. So we falsely predicted negative tweets quite a lot. We also falsely predicted positive tweets quite a lot. And yeah, so a lot of work to do, especially with this XGBoost. This one picked negative a lot more than it should have. And then also picked positive, or no, that's in the right spot because we want to go diagonal. But yeah, these are just simple confusion matrices to kind of show where our work is doing. For example, if you look here in random forest, we almost never pick negative. So it's working slightly differently than the XGBoost and cat boost. And we might need to focus on that if we want to see which model is the best. So, yeah, we got a few things we're trying to work on. We're going to try, instead of doing a train test split, we're going to do some k-fold, which is a different way to bucket data together. And we are also going to try to do the data sampling before the training split and instead do it on the whole data set. That's a few things we're looking forward to. And hopefully this is done by the end of July. So, yeah, I hope that this little look over my project helped with your understanding of research going into sentiment analysis and how AI is applied to the computer science field. Thank you.